Howdy. Today we're going to talk about 11-1 geometric sequences. Now, as you know, we're going to put this in with Chapter 4, so this is the last section we're going to talk about in Chapter 4 before your Chapter 4 test. Two vocabulary words today: geometric sequence, and this is a sequence in which the ratio of successive terms is a constant called the common ratio. And then the common ratio is the ratio of any term in a geometric sequence and its previous term. Now, the difference between a geometric sequence and an arithmetic sequence, which we talked about in 4-6, is that in an arithmetic sequence you are adding or subtracting the same number. In a geometric sequence, you are either multiplying, well, you're pretty much multiplying by the same number, I should say, because we're going to deal with ratios. So you're multiplying by the same number. Okay? So the first type of problem you'll see is just where they give you a geometric sequence and they ask you to find the next three terms. So in order to find the next three terms, you need to know what R is. What's the common ratio of the sequence? To find that, we divide each term by the one before it. So for example, this one, 4 divided by 1, would be 4. So that would be my common ratio. And I could do that really with any term in the sequence. If I went to 16, I divided it by the term before it, I get 4. If I go to 64 and divide it by the term before it, I get 4. So I can see that no matter which term I choose, if I divide it by the one before it, and before it is important, okay, this can get a little confusing sometimes, then I will find the common ratio. And once I've found out the common ratio, I just multiply each term by that common ratio to get the next three terms. So, for example, to get the next term, I'd have to do 64 times 4. And when I do that, I get 256. So 256 would be my next term. And then I'm going to have to do 256 times 4. And I believe I get 1024. And then I have to do 1024 times 4, which is going to be 4096. If I can do my multiplication right here. Let me just double check that. Yep. So there's my next three terms in the sequence. Let's look at another one that's a little bit harder. Now, again, I want to find R. And remember, R is when I take any term in the sequence and I divide it by the one before it. So let's say I take 3, I got to divide that by -9. Now, a lot of you might say that that's -3. It's not. Okay? This is a fraction. I have to reduce it, and it comes out to -1/3. Let's try a few others just to make sure we're right. So if I take -1, divide it by the term before it, well, that gives me -1/3. What about if I take 1/3 divided by -1? Well, that's going to be -1/3 as well. Okay, so it seems like our common ratio is -1/3. So then I'm going to find the next three terms. Well, I got to take -1/9 times -1/3. That's going to give me 1/27. So that's one term. Then I got to do 1/27 times -1/3. It's going to give me -1/81. So that's my second term that I'm finding. And then I have to do -1/81 times -1/3. And that's going to give me positive 243, I believe. So my next term would be 1/243. Okay, so sometimes you will be multiplying by fractions. Keep that in mind. Now, just like with arithmetic sequences, we wanted to be able to find any term in a geometric sequence. So again, we wanted to come up with some sort of equation that would allow us to find any term that we wanted to. So once again, I'm going to take you through this table to try to show you how did we get to this equation. So here's the sequence I'm going to talk about: 3, 6, 12, 24, 36. And remember, the first term is always called a sub 1, and in this one, my first term is 3. So then, to get to the second term, I have to multiply by my common difference, or common ratio, which is 2. So 3 times 2 is 6. So 2 is just 2 to the first power, so that would be my first term times my common ratio to the first power. Now to get to the third term, I'm going to have to multiply by 4, right? 3 times 4 is 12. Well, 4 is the same as 2 to the second power. Remember, 2 is our common ratio. So, if I put that in algebra, I have the first term times my common ratio to the second power. Fourth term, I have to get to 24. Well, 3 times 8 is 24. 8 is the same as 2 to the third. So, if I put it algebraically, first term times my common ratio to the third power. Now, hopefully, once again, you're noticing a pattern. Notice what term I'm on. Notice what power I use. The relationship between them is that the power that I use, or the exponent that I use, is always 1 less than the term that I'm on. So therefore, when I'm finding the nth term, remember nth term means any term in the sequence, I take the first term times my common ratio to the power of n minus 1. Okay? And that is, in fact, our formula for geometric sequences. And once again, you will need to know this formula. So a sub n, which is the nth term, is equal to the first term times r, which is the common ratio, to the n minus 1. So let's put this into practice here. The first term of a geometric sequence is 500. So remember, that's a sub 1. The common ratio is 0.2. So remember, that's r. What is the seventh term of the sequence? Well, a sub 7, so this is n equals 7, is going to be my first term times r, which is 0.2, to the sixth power. Remember, it's 7 minus 1. So then I got to figure out what's 0.2 to the sixth power. And let's see, that's going to be I gotta do this on my calculator. I don't know it off the top of my head. We got lots of zeros here. Actually, I should have known this because it's just 2 to the 6th power. So sorry about that. 500 times 0.00064. Okay? And then I times that by 500. And that end up with 0.032. So that is my seventh term of that sequence. Let's look at another one. A sub 1 is 5, r is 2. What's the sixth term of the sequence? So we want a sub 6 equals my first term times r to the 5th power, because it's 6 minus 1. So 2 to the 5th power is 32. So then I have to do 5 times 32, which is 160. So that's how we use our formula for geometric sequences. And then finally, they will put it into story problem form. So the table shows a car's value for 3 years after it's purchased. The values form a geometric sequence. How much will the car be worth in the 10th year? Well, first of all, I have to figure out what R is. And remember, to get R, I take a term of the sequence and divide it by the term before it. I believe here I'm going to get 0.8. So my common ratio is 0.8. Now I want to find the 10th term. So A sub 10 equals my first term, which is 10,000, times my common ratio, which is 0.8, to the 9th power. Remember, it's 10 minus 1. So then I want to do 0.8 to the 9th power. So let's do that. Again, I'm using my calculator here. Now, that's kind of a long decimal when I do 0.8 to the 9th power, so I'm going to write down part of it here. And when I'm doing this and using my calculator, I can just kind of leave that decimal in my calculator. And then, all I want to do next is times that by 10,000. And when I do that, I get 1342.18 if I round it, and I want to because I'm talking about dollars and cents. So after 10 years, my car that I bought for $10,000 is worth $1,342.18. Okay? Once again, if you have any questions, make sure to make note of them and ask me about them tomorrow, and I will see you then.